Have you ever noticed how a summer heat wave just feels so much worse when you're in the city? Well, I'm here to tell you it is absolutely not just in your head. But what's really happening isn't simple addition. It's not just that the city is a few degrees warmer. The science shows our cities actually act like a giant magnifying glass, creating this dangerous feedback loop that doesn't just add to a heat wave, it multiplies its intensity. So let's ask that question head on. Why does stepping onto a city street during a major heat wave feel like you're stepping into an oven? To really get to the bottom of this, we need to understand two key forces at play. First, there's the city itself, which literally creates its own island of heat. And second, there's the land all around it, which can give a heat wave a dangerously long memory. Okay, so let's dive into the first piece of this puzzle. It's a concept you've probably heard of before, but you might not realize just how massive its impact is. We're talking about the urban heat island. Simply put, an urban heat island, or UHI, is exactly what it sounds like. The city becomes a literal island of heat sitting in a much cooler sea of countryside. And it's a direct result of how we build our world, all the choices we've made in creating our urban environments. And this is where you can really see the why. Out in the countryside, you've got vegetation, you've got soil. When the sun beats down, a ton of that energy is used to evaporate water from the plants and the ground. It's a natural cooling process. But in the city, forget about it. We've replaced all that green with asphalt, concrete, and dark buildings. These materials are absolute pros at absorbing and holding on to heat. And there's almost no water around to provide that amazing evaporative cooling. And we are not talking about a small difference here. The urban heat island effect alone can make a city's surface a blistering 4 to 5 degrees Celsius hotter than its rural surroundings. And get this, that's the baseline. That's how much hotter it is before a heat wave even rolls in. But the city itself is only half the story. To really understand why heat waves get so intense and last so long, we need to look down at the soil under our feet and explore this fascinating concept that acts like a kind of memory for the weather. It's called soil moisture memory. And you can think of it just like that. The ground actually remembers if it's been wet or dry. So if you have a long period of drought, you get this dry soil that holds on to the memory of being dry. And this memory doesn't just last for a day or two. It can influence weather patterns for weeks, sometimes even months. Now, this is a brilliant illustration of what that memory actually does. Don't worry about all the technical numbers here. Just look at the shapes of those curves. When the land is dry and has that persistent memory of being dry, it fundamentally changes the profile of a heat wave. So instead of a short, sharp spike in temperature that cools down pretty quickly, the heat wave gets stretched out. It becomes that wider, flatter red curve. It just persists for longer at those extreme temperatures. That dryness becomes a self-sustaining engine that gives the heat wave some serious and dangerous staying power. So yeah, the takeaway here really is that simple. Parched, dry land, with its long memory of drought, doesn't just make heat waves hotter, it gives them endurance. It makes them stick around for a lot longer. Okay, so let's put it all together. We've got our city, which is already a hotspot, basically superheating itself, and we have the surrounding landscape, which is primed by drought to make any heat wave last longer. So what happens when these two powerful forces collide? Right, so you have this massive weather system, a huge heat wave, just dragging hot, dry air across an entire region. And then it slams right into the pre-existing hotspot of a city. This is where things get really dangerous, because it's not just addition anymore, it's multiplication. And the research spells this out perfectly. I know this quote sounds super technical, but the idea behind it is actually pretty straightforward. Latent heat is the energy used for evaporation, which, as we know, cools things down. Sensible heat, on the other hand, is the heat you can actually feel. It's the energy that just raises the air temperature. Well, cities are terrible at creating that cooling latent heat, but they are incredibly efficient at pumping out sensible heat. And the result? It amplifies everything: the intensity of the heat, the size of the area affected, and how long the misery lasts. And all of this creates a really nasty, vicious cycle. So first, the heat wave arrives. Then, the city, with all its dark, dry surfaces, takes that solar energy and just pumps it directly into the air as raw, sensible heat, supercharging the whole event. But then something else happens. All of that rising hot air actually changes the atmosphere right above the city. It deepens what scientists call the atmospheric boundary layer, which is just the layer of air closest to the ground that we all live in. And by making that layer deeper, the city essentially creates a thicker, heavier blanket of hot air that traps even more heat right where we are. And this number just shows you the incredible scale of that effect. During a heat wave, a city can create an extra 90 meters of hot, stagnant, heat-trapping atmosphere right above it compared to the countryside. The city literally builds its own heat dome, making the situation on the ground so much worse for so much longer. So, the science is clear and, it's frankly a little scary. But the good news is understanding the mechanics of this vicious cycle is precisely how we can learn to break it. And we absolutely have the strategies to do it. We can actually fight back against the physics. We can increase albedo, which is just a fancy word for how reflective surfaces are, with things like cool roofs that bounce sunlight back into space. We can reintroduce those latent heat fluxes by adding green spaces and parks that bring back natural evaporative cooling. And we can design our cities smarter with ventilation corridors that let the wind flow through and break up all that stagnant, superheated air. This interaction between our cities and our climate is an incredibly powerful force, but it is one we can influence. So the next time you're walking through your city, just look around and ask yourself, is this place built to be an oven, or is it being redesigned for a cooler, more livable future?